Hello everyone, welcome to Math with me. Today I'm going to discuss about geometrical shapes, area and volume. Before getting to learn area and volume, let us learn or understand what is two-dimensional, what is three-dimensional figures. Two-dimensional shapes or figures are the plane figures which has both length and breadth, or the radius will be given for the circle, any two quantities. But for three-dimensional shapes, they have both length and breadth as well as the height. Example for two-dimensional is the circle, triangle, square, which is on the plane. In three-dimensional figure, it is more like z-axis will be included along with x and y axis. I have explained the Cartesian coordinate system in the linear equation. So this is the three-dimensional shape. You may have observed in two-dimensional movie, which is a normal movie, where the height of the objects or the depth of the objects will not be well defined. Whereas in 3D movie, the depth or height of the objects will be very well defined. Given in two-dimensional shape, we can find the area of that shape or the perimeter, which is a fence around that shape, or if it is a circle, then we can find the circumference of a circle. But volume cannot be found for two-dimensional shapes. For the three-dimensional shapes, we can find the volume of the three-dimensional shape and the surface area around the three-dimensional space. Now let's move on to polygon and polyhedron. Polygon is a two-dimensional shape formed with straight lines, and the figure should be closed, and it must have at least 3 points. 3 points or 3 vertices, 3 edges. Here the circle is not a polygon as it has a curved surface. Any figure which has circle or curved surface is not a polygon. What are polyhedrons? Polyhedrons are the three-dimensional closed shape formed with straight lines. It must have at least 3 points, as well as it must not have any curved surface. This cone is not a polyhedron. This is a polyhedron. This is a triangular prism. This is a polyhedron as it does not have any curved surface. Now I am using this as a clue card. For two-dimensional shapes, the area for the circle, the area is pi r square. Area of the triangle is half times base into height. Area of square is L square. Area of the rectangle is L into B. The SI unit is meters into meters, and it is meter square. How can you derive the volume of the three-dimensional shapes using two-dimensional shapes? I'm going to show you now. Suppose if you want to find out the volume of a cylinder using the area of a circle, then how can you find the volume of a cylinder? So take the area of the base figure, that is the base figure is here the circle, the area of a circle into the height of the cylinder will give you the volume of the cylinder. That is essentially many two-dimensional circles. If you pile it in layers, then it forms the cylinder. In case number 2, it is a triangle. Many triangles, if you pile it in layers, then it will form the triangular prism. So you will take the area of this base figure into height. Here the base figure is a square, into height is also the length of a side. So it is L cube. Here base area of base is 2L into B into the height will give you the volume. The SI unit of volume is meter cube, as the area of the base figure will be having meter square, and you are multiplying with the height meter, so it will be meter cube. Suppose the figure has the sharp edge like this. The sharp edge is apex, and the base here is the triangle, the circle, rectangle and the square. Then the volume will be 1/3 the area of the base figure into height. Here is the formula for sum of interior angles of the polygon. I have taken 5 here. Pentagon, I did get 540. as the sum of interior angles, and for each angle if we want to obtain, then divide it by number of sides or vertices. It is 5 here in this case. 108 is the interior angle for the pentagon. What is the exterior angle? Then you subtract it by subtract the interior angle what you have obtained from 360, then you will arrive at the exterior angle. If you want to find the diagonal number of diagonals for the pentagon, then this is the formula I'll use. N into n minus 3 divided by 2. Here it is pentagon 5 into 5 minus 3, that is 2 divided by 2, that will be 5. So 5 diagonals can be drawn for the pentagon.